Hello Internet, my name is Quinn and this is Blondihacks. Now, we all get into model engineering with visions of wearing leather aprons and tuning valve gear amidst clouds of steam and coal smoke. The reality is, we often spend an entire week making plumbing fittings. That's today. We're going to make the feedwater plumbing system for the locomotive that lives entirely in and around the tender. It's actually pretty neat, so let's go. If you've been following this series, then you know that hiding inside this water tank like a trash panda in my compost bin is a mechanical water pump. And this is the backup pump, or supplementary pump, I suppose. There's a fitting on the back that you can't see, and we need to run a water line over to the front, and also a second water line from a pickup point for the main axle pump on the engine, so that they can both get water out of the tank. If you find yourself making plumbing fittings, then your best friend in the whole world is by far brass hex bar stock. As a model engineer, I keep this stuff in many sizes in stock because it really saves you a lot of time. Anytime the largest diameter on a part has a hexagonal profile, you will always save yourself a lot of time by starting with hex bar stock. This first fitting that I'm making is a bulkhead. It goes through the floor of the tender and allows the plumbing to get from the pump and the pump intake down through the floor and then into the piping that runs underneath the floor of the tender forward towards the engine. I start by putting the thread on the end, which will receive the union nut. Now I need to drill for the water passage. This is an L-shaped fitting, so I need to drill a very deep but blind hole to a very specific depth so that it can meet up with another passage. To do that, I use a feeler gauge to find the end of the part on the drill. And that's because the feeler gauge will prevent me from going too deep as a result of the end of the drill being inside the center that was in that part. That was a 20 thou feeler gauge, so I have an indicator on my tailstock set to -20, and then I can feed in, and when the indicator hits 0, I know that drill is going to be right on the surface of the part, and then from there it's going to start cutting, and I can measure my depth very, very accurately doing that. Finally, to part it off accurately to length, I find the edge by sweeping my scale over the end of the part until I can just feel it scraping on that parting blade, zero my DRO there, then run down to where the part needs to be, and part it off. You'll note that for all of these operations that you're going to see with hex bar stock, I always stop at some point and go in with a chamfering tool to put a nice chamfer on the corners. Hex profiles look really, really nice with a chamfer on them, and they also feel much better when you're handling the parts. You'll see this on commercial nuts. They always have those little chamfered corners. It's a really nice detail that's very easy to create, and a chamfering tool does a much better job in this case than a file, which is what I might normally use for a quick light-duty chamfer like that. I mentioned this was an L-shaped fitting, and now it's time to make good on that promise. I'm using my Heimer edge finder to find the end of the part and then also to center up on the y-axis. That will allow me to get the cross passage in exactly the right place. One of the trickier things with some steam fittings is when you've got multiple passages that all need to intersect just right inside that part to make it into a manifold, or in this case an L-shaped fitting. I center drill that and then drill through, and if you feel that drill break into your mating passage, then you know you've done your job right. It's a very, very good feeling when that happens. And if you did it right, you can create old chipful, the geyser of chips. Finally, this gets a counterbore, and that's to hold a piece of copper pipe. This is going to be what's underneath the floor of the tender. That'll be silver soldered in place right into that counterbore like that. That's a really nice fit. There's the final bulkhead fitting. I actually need two of those. There's a second one that's essentially identical with slightly different dimensions. I won't bother showing you that. The next fitting is a drain valve that sits under the floor of the tender and allows us to drain the water out. This also starts with hex bar stock. This is a really simple part. It's a thin hexagonal profile with a shoulder turned on it and a hole drilled and tapped through the center where we can thread in a drain plug. This also gets a little bit of a counterbore in the bottom of it for a length of copper pipe, a very short length. This sits underneath the tender between the trucks, and there's a little bit of pipe that sticks down, kind of a urethra, if you will, that allows it to drain between the trucks. and Yahtzee. That all seemed to go well. That part is almost finished. Now, imagine I had done all of that with the correct size hex bar stock. It would look like this. Isn't that better? Yeah, that's the thing that happened. That's a mistake that was actually 6 months in the making, because not only did I use the wrong size hex bar stock, I actually ordered the wrong size hex bar stock. So I didn't have the right stuff when I realized my mistake and needed to make it again. So I grabbed some round bar, and I had to manufacture some larger hex bar. I have actually 2 parts in this plumbing set that need to be made from the same larger size. This is a fairly standard hex collet block setup for making a hexagonal profile, with the addition of the machinist jack and the clamp outboard. This setup isn't very rigid. I've got a lot of stick out because I want to make a long hex profile all at once, so the machinist jack holds things tight at the other end. It does mean for each face I have a little bit more fussing to do because I got to unclamp it and reclamp it. The secret sauce to this setup is the fact that the little round section at the end remains all the way through, so the clamping height is always the same throughout all of the cuts, even though we're actually making it smaller in arbitrary ways as we go. Now I can just cut that little chunk of round stock off the end, and in fact I can even chuck the entire piece of round bar in the lathe at this point to maximize efficiency on material use, or if I need to, I can also cut off the hexagonal chunk and just use that. Now back to that drain valve that I was making. I've got it set up upside down in the mill, and I'm dialing in that boss that was turned concentrically in the center because we have to make a tiny little bolt pattern, or bolt circle rather, centered on that threaded fitting. I'm using my indicator on my mill spindle clamp for this. This is a shop-made tool. I've got a video on making this if you were interested. It works super well. Then once centered up, I can use the bolt circle function on my DRO to drill a tiny little bolt circle all the way around. This is a 3-bolt pattern. Unfortunately, one of the holes landed right on my parallel because I didn't plan this very well. However, I don't have to throw away the setup. We've got a lot of work invested in it. I can bring the drill down and just touch the top of that parallel, zero the quill DRO there, then drill my hole, stopping just 5/1000ths short of 0 on the quill DRO. And that will not touch the parallel, but we've effectively drilled the hole all the way through. You'll see what I mean in a second. Once I've drilled all 3 holes, then I go back around my bolt circle again and tap all of them. Of course, one of those I can't tap all the way through because there's still 5/1000ths of material right at the bottom of that hole on top of the parallel. And there's the part so far. You can see we've got 2 90% of a third hole. Then over to the bench vise, and I can use a pin vise with the tapping drill size and just punch through that last 5/1000ths of the brass at the bottom of the hole, then finish the threads all the way through the hole. That's also easy because we don't have to worry about keeping it straight. Most of the threads were already there from the mill. We're just finishing the last couple at the bottom of the hole. This is a really simple technique that you can use anytime you've got a bolt pattern that lands on top of a parallel or you otherwise can't drill all the way through. Often with a setup like that, where there's coaxial indicating involved and bolt circles and so on, you've got a lot invested in that setup. You don't have to throw it away just because, like me, you always forget to check for where the parallels are going to land. Next up is the drain plug, which is a very long, thin part. So I center drilled that, pulled it out for tail support, then turned down the end and cut an undercut for a thread that will go on there. Lathe noises. Next, the whole center area of this gets turned down to a thinner diameter, which just basically looks nice. I think that's the only reason for it. I chose a symmetrical 30-degree tool for this, which allows me to plunge straight into the work, feed one way, creating a nice filleted shoulder on that end, then feed the other way and create a similarly filleted shoulder at the other. With a tool like this, you can cut both ways equally well, and it leaves a nice finish. And finally, I put those threads on the end. I probably should have done this sooner when the material was still thicker and thus stronger. If you're not careful, it is possible to bend or otherwise distort a piece with a threading die like that, but I seem to have mostly gotten away with that. And then finally, part it off to length. If you're wondering why a drain plug needs to be this long, it's so that you can reach it from the hatch at the top of the tender, even though the drain valve is way down in the bottom. So, ergonomics. Next up is the intake for the main axle pump that's going to be eventually in the locomotive itself. This is made from that shop-made hex bar stock as well. So this gets drilled through and tapped. The interesting feature here is a large 90-degree internal taper at the top of this. Acts as kind of a funnel to direct water into the pickup. I thought I could get away with doing this with my chamfering tool. It's a question of whether there's enough clearance underneath the tool to do this, and it looked like maybe there was. It was going to be close, and well, yeah, too close. I did not, in fact, have clearance to do this. It was rubbing quite a bit. It was chewing up the material, pushing it around, squeaking, and generally making a mess. So I had to give up on that and do this the correct way, which is to put a boring bar on my compound set at 45 degrees and single point turn this internal taper. That does a much nicer job. That is a beautiful looking part. Now there's a similar taper on the underside of this part, which of course is not accessible. So one way to do it would be to part it off and flip it around and do the under taper as a second operation. However, we can be clever about this because it's brass. I can get the parting blade started, then come back in and use the chamfering tool as a parting tool essentially, and just plunge all the way in with the chamfer tool, which is going to put that big taper on the underside of the part, then finish with the parting blade. We were able to plunge with an aggressive form tool like a chamfer tool because it's brass, and that's easy to cut. Next up are a series of cones. These are used as part of the pipe unions. There are as many designs for these as there are model engineers, but this is Kozo's design. It looks rather like a barbed hose fitting, if you've seen those. It's essentially a pipe with a 45-degree angled barb near the end. To achieve that, I'm going to use my chamfering tool as a turning tool, which will allow me to create the final diameters and the 45-degree chamfers on the small hose barb area all at the same time. Now, it's not actually a hose barb. It's a tapered section, which you would think would be part of the sealing function of the union cone if you're familiar with this style of fitting, but actually no, it's just a shoulder to retain the union nut. In Kozo's design, the square end of the fitting does all of the sealing. Oftentimes with these cone fittings, it's the cone surface against a sharp edge that makes the seal, but that's not how Kozo's work. I've never tried this style of union fitting before, but obviously they work for Kozo, so it'd be interesting to try them. And a Yahtzee. I realize if you've not seen this style of pipe union, this fitting probably makes no sense, but hang on, I'll show you how it works in 1 second. But first we have to make the union nut, which once again starts with hex bar stock. Now I'm going to show you a really amazing trick you can do with center drills. Pay attention, because I guarantee you've never seen anything quite like this. I'm going to bring in this center drill. Now pay attention. There, now you see what's happening right now? Pretty crazy, right? I bet you didn't know you could do this with a center drill. I know, really, really something. If you take away nothing else from this video, make it this trick right here. This is probably the single best thing I've ever learned in the machine shop. Look at that. Wasn't that incredible? Man, sure glad I caught that on film, because what a trick. After drilling through, the union nut now needs to be counterbored very, very accurately. So I'm once again using the feeler gauge trick to get a perfect depth on this drill. This is really the secret sauce that makes union nuts work. You have to create a very thin shoulder at the bottom of them with threads that go right to the bottom of that shoulder. It's a little bit tricky to do. The secret is very, very accurate drilling and a really good bottoming tap, so you can get threads as close to that shoulder as you can. And that shoulder has to be just the right thickness. If it's a little too thick, there won't be enough reach for the threads of the union nut to reach over the cone. And if it's too thin, it won't be strong and it'll break. Once I Yahtzee this off of there, you'll see what I mean. Here's the inside of that nut. You can see there's a thin shoulder with threads that run right down to that shoulder, or at least as close as we can get. That's really, really important, because now you'll see how it relates to that barb-like cone fitting that we created, which slides inside, and it has to wrap around the barb section. That's what retains this all together, so that the nut can pull the barb fitting into the mating piece of the other end of the fitting, and it has to have just enough thread depth to reach over onto the mating fitting and tighten down without bottoming out, and still have enough strength in that shoulder to pull everything tight. Here's how it mates up with, for example, one of those L fittings that we just made. You can see how the two pieces inside seal against each other, and then the union nut pulls them all together. If those tolerances all aren't just right, then something isn't going to seal. And this particular fitting is made for a hose that slips on over the end like so, but you can also solder these onto hard pipes. Those fittings are surprisingly tricky. I've messed up a lot of them over the years. Here we've got most of the parts now of the whole plumbing system. You can kind of see in this mock-up how things basically are arranged. Next up is a hard line that connects the pump output to one of those bulkhead fittings that goes through the floor. So I'll kind of mock everything up in its final positions from underneath so that I can get that pipe to be the correct length There's a little nut that holds that in place that I made off camera because it wasn't exciting. A lot of these parts I've also made a bunch of that I didn't bother showing you. So like those union cone fittings, there's 4 of those. There's 4 union nuts. There's a lot of multiples of all of these parts in this whole plumbing system. I have this little tubing bender that works great for model engineering. The only downside to it is that the minimum radius that it can do is a little larger than Kozo has in mind for this pipe. So I couldn't quite route it exactly like he would like you to. The fitting lands kind of in the middle of the radius. So I had to do a little bit of a Z kind of profile in both dimensions because the larger radius means the pipe has to backtrack a little bit to get to the right place. That seemed to work okay. It's just not quite as tidy as the drawings. That did take me a few tries, as you can see from the pipe detritus in the background, or detritus as we say in the biz. Once I know for sure that pipe is the correct shape and length, then I can solder those barb fittings, those cones, onto the ends of the pipe, make them permanent. I'm proud to say, for the first time in recorded history, for me at least, I remembered to put both union nuts on the pipe before soldering the ends. This has literally never happened to me before, at least not that I can remember. It's almost gotten to the point where I automatically make extra cone fittings and add extra length to every pipe, just to account for the fact that I know I'm going to forget to put the union nuts on the first time I solder the fittings on. That sound you hear is every model engineer in the world solemnly nodding their head in understanding. If I did my job right now, that pipe should now tighten down onto both of those fittings, and we should have a really nice looking permanent connection between the pump and that first bulkhead. While I'm here, I will test fit the drain plug as well, the drain valve, which goes under the floor, and there's a matching 3-hole bolt circle in the floor that amazingly lines up perfectly, which is great because I drilled that about 6 months ago, maybe a year. It's been a while. Great job, Past Quinn, you did it right. And in goes the drain plug, and you can see why that's so tall now, because you have to be able to reach it from the water hatch above. I'll test fit the main axle pump intake as well while I'm here. This is a little funnel that sits on the floor. Okay, so far so good. Next job is to get the pipes routed underneath the floor to connect to the front where the locomotive is of course going to be. Those L-shaped bulkhead fittings get pipes soldered into them. I need to mark and bend these pipes. They have a section of it that's rigid and then it bends down at the end to make clearance for some flexible lines that connect. And make sure the truck's clear there as well. They can rotate through their full range without touching the pipes. That's good. Here's what those pipes look like, all soldered in place. I also added the little urethra pipe to the drain, as I said. And you can see I've also added a metal grating to the pump intake just to keep the squirrels out. That was done the same way as on the pump intake. Then on the front there will be these lengths of rubber hose which allow the pipes to bend in the area of the drawbar so they can connect to the locomotive. I've left those over length because I don't know how long they need to be yet. All those pipes and stuff need a way to hold them in place, so I'm going to make some pipe clamps next. I rough cut and machined some strips which I annealed and marked center lines on, and I'm going to bend these into a D-shaped pipe clamp to hold the rigid pipes underneath the floor of the tender. I turned 2 mandrels, one the size of each of those 2 pipes. Those pipes are actually different sizes. I know that's not obvious on camera, but they are. And since this is just 40 thou aluminum sheet and it's annealed, I can use the mighty power of my fingers to bend it around that mandrel, get it the correct shape. Then using a straight edge, I can mark where the sides of that clamp need to bend 90 degrees outward to form the kind of D shape. For those little bends, a pair of seaming pliers worked really well. This is an HVAC tool for doing duct work. It's basically like a tiny handheld press brake. Works really well for this sort of thing. Those little mandrels got a third use over on the mill. I used them as a centering pin so that I can get the bolt pattern for these clamps centered across the area where it's going to be clamping. Centered up on the Heimer, center drilled and drilled the 2 bolt holes, then took it over to the belt sander with my little end rounding fixture that you've seen before, and I rounded the ends of those clamps. Now imagine all of this upside down underneath the tender. You can see those little clamps are going to go there and there to secure the 2 rigid pipes. Well, why mock up when you can just install? I got everything flipped over. I'm going to remove the trucks, and that'll give me access to line up the hard lines where I want them to be. I want to make sure they're nice and parallel and that they come out at a nice place at the front of the tender. And then I can transfer punch the bolt holes that I'm going to need to create in the frame to hold these pipe clamps in place. Fortunately, I can fit this whole thing in my mill. I didn't have to disassemble too much to drill and tap these holes. And since the frame is powder coated, I don't have to worry about damaging the powder coat. It's really nice that way. If this was paint, there might be a worry about ripping off a whole chunk of paint when you drill a hole in it, but not so with powder coat. Those clamps go on there. They're not quite as tight as they could be. The pipes do actually still have some movement in them, and that's not a big deal. I can just pad them a little bit with some paper so they're snug. And that's actually kind of a feature because that adds a little bit of anti-chafing as well. Like you see that on cars, but to be clear, locomotives are not cars. They're not nearly the high vibration environment that a car is, so you don't have to worry so much about everything chafing everything like you do in cars. I'm really happy with that though, so I'll get the pump back in its home. All of this is going to need some sealing and so on before it's done. It's all going to come apart again, but for now I can get it back together again. Now let's take another look at these hoses. They need clamps to keep everything tight. I made more strips just like you saw, and this time I used a mandrel the size of that rubber tubing and my parallel jaw pliers to squeeze around there and make some pipe clamps. These were cut to length and then drilled and rounded over once again on the belt sander end rounding fixture. Then, nuts. Let's get all of these pieces together and see if these are actually going to function as pipe clamps. I've never made my own hose clamps before, so I have no idea if this is going to work. Get the union fitting in there like so. Tighten that down. And that feels like it's getting tight. That seems like it's good. It bottoms out, so it may not be clamped enough. But when I tug on that, it seems very, very tight, so I guess it's fine. Now, that's okay though, because we're actually going to be adding a little more thickness to this. The next step Kozo suggests is armoring these hoses with some metal mesh wrapping like this stuff here. You could probably harvest this from old coaxial cable from your television, something like that. But you can also just buy it from McMaster on a roll, and it's really not very expensive. If you squish it end to end, then it gets much larger in diameter, and you can slide it over whatever you need, and then pull it tight. And then my clamps will go down over top of that, and clamp everything together and hold everything in place. The idea with this armoring, this metal shielding on the hoses, is that the hoses run through the drawbar area into the back of the locomotive, and that area is exposed potentially to falling ash and cinders and other hot things that could land on those hoses and damage them. So these hoses will now be protected from anything that lands on them. Let's give the system a little test and see if the feed water side of it is working. I've got a little tray under the pickup on the hand pump. Let's see if I can get water out the other end of the system. These pumps always take a few strokes to prime, but once it's primed, there we go. Look at that. We got water coming out. So it's working. That's very, very cool. Now, moving water is fine, but this whole system needs to be able to force water into the boiler under pressure. So I am going to be pressure testing this whole system, make sure all of my fittings and seals and everything stand up to that, make any fixes that are needed. But for now, it shifts water, and that's really, really neat. I gotta say, this was pretty fun to make as plumbing fittings go. It was a lot of work, a lot of little fiddly bits, and a lot of mass production of little bits, but the system works, and I'm pretty excited about it. Our future locomotive will be able to get water. Well, that's all the time I have this week. Thank you very much for watching, and thanks especially to my patrons who make all of this content possible. You guys are keeping this ridiculous show on the road, and it really means a lot to me. I hope it means a lot to you as well. And I'll see you next time.